Hello my dear students, in this lecture we are going to see one previous year GATE numerical. This question was asked in GATE 2019 and this question is based on finding the LMTD of parallel flow heat exchanger. So let us understand the question. The question is, hot and cold fluids enter a parallel flow double tube heat exchanger. Now here they have given parallel flow heat exchanger. So let us first draw parallel flow heat exchanger. Now for parallel flow heat exchanger, the cold and hot fluid enters from the same side. Let us say the left side is entry for hot fluid, that is Thi is the inlet temperature of hot fluid, and let us say Tho is the exit temperature of hot fluid. Therefore, there will be a hot fluid flows from left side to right side. Again, for parallel flow, the cold fluid also enters from the left side and flows towards right side. Therefore, let us say there is a Tci is a cold fluid inlet temperature and Tco is a cold fluid exit temperature. Therefore, the flow of cold fluid also from left to right over here. Right. Now, hot and cold fluid enter a parallel flow double tube heat exchanger at 100 degrees Celsius and 15 degrees Celsius. Therefore, this 100 degrees Celsius is inlet temperature for hot fluid and 15 degrees Celsius is inlet temperature for cold fluid. Therefore, they have given Thi, which is 100 degrees Celsius, and Tci, which is 15 degrees Celsius. Right. Then, respectively, the heat capacity rates of hot and cold fluids are. Heat capacity rates is nothing but product of mass and specific heat. Therefore, Ch is product of mass and specific heat of hot fluid. Therefore, mCp of hot fluid, which is nothing but C of hot fluid, is equal to 2000 watt per Kelvin. And here C means mCp of cold fluid. mCp of cold fluid, which is nothing but C of cold fluid, is equal to 1200 watt per Kelvin. Right? It is 2000 watt per Kelvin. It is 1200 watt per Kelvin, respectively. If the outlet temperature of cold fluid is 45 degrees Celsius, now for this cold fluid, outlet temperature, that is Tco, is equal to 45 degrees Celsius, right? Then the log mean temperature difference LMTD of the heat exchanger in Kelvin is. Now we have to find log mean temperature difference in Kelvin, right? Now my dear students, this left side temperature difference Thi minus Tci is called delta T1, and the right side temperature difference in the temperature profile, that is delta, that is Tho minus Tci, is called delta T2. And my dear students, here the log mean temperature difference LMTD for any heat exchanger is given as delta T1 minus delta T2 divided by ln of delta T1 divided by delta T2, right? So my dear students, here to find LMTD I have to calculate delta T1. So delta T1 is nothing but Thi minus Tci, that is left side temperature difference, right? Thi is given, Tci is given, so let us find this delta T1, which is nothing but 100 minus 15, which is equal to 85 degrees Celsius. Again, delta T2 is equal to, this delta T2 is Tho minus Tco, therefore is equal to Tho minus Tco, which is equal to Tho is given, Tho is unknown, Tco is given only right here, therefore it will become Tho minus Tco is 45 minus 45, right? So my dear students, here first of all we have to calculate this Tho, right? Now to calculate this Tho, again we have one basic relation of heat transfer through the heat exchanger. Now heat transfer through the heat exchanger will be equal to, if I consider cold fluid, for cold fluid mCp of cold into temperature difference of cold, therefore it will become mCp of cold fluid into temperature difference, that is Tco minus Tci of cold fluid. And if I consider hot fluid, then it is equal to mCp of hot fluid into temperature difference of hot fluid, that is Thi minus Tho, right? Because whatever may be the heat lost by the hot fluid is equal to heat gained by the cold fluid. Therefore, heat lost by the hot fluid is mCp of hot Thi minus Tho is equal to heat gained by the cold fluid, which is mCp of cold Tco minus Tci, right? Now here this mCp of cold is nothing but 1200, mCp of hot is 2000. So let us put the values and let us find here Tho. Therefore mCp of cold is 1200 into Tco is given 45 minus Tci is 15 is equal to EMCP of hot is 2000 into THI is given 100 minus THO is unknown. Now my dear students, in this complete equation only THO is unknown. So let us solve this equation for THO. If I solve this equation, I will get this THO as 82 degrees Celsius. So my dear students, let us use this THO value to find delta T2. So can I say this delta T2 will be equal to THO minus 45. THO is 82, therefore 82 minus 45. Therefore this delta T2 will be equal to 37 degrees Celsius. Now once you calculate delta T2 and delta T1, let us find LMTD by using this formula. Therefore here LMTD is nothing but log mean temperature difference is delta T1 minus delta T2 divided by ln of delta T1 divided by delta T2. Therefore this LMTD will become delta T1 is 85, right? Delta T2 is 37 divided by ln of 85 divided by 37. So my dear students, let us solve this for LMTD, log mean temperature difference. Then I will get answer as LMTD will be equal to 57.71 degrees Celsius, right? So my dear students, here they are asking in Kelvin. Now what will be the answer in Kelvin? The answer in Kelvin is equal to same 57.71 degrees Celsius is equal to degree Kelvin also, right? Therefore we have to write here 57.7, right? Now my dear students, this is a LMTD, that is log mean temperature difference. It is a temperature difference. Now my dear students, the temperature difference in Kelvin, temperature, what I am saying, temperature difference in degree Celsius is always equal to Kelvin temperature difference, right? Here I am not saying temperature in degree Celsius is not never equal to temperature in Kelvin, but it is a temperature difference, right? So don't get confused. Whatever may be the answer we have calculated is temperature difference in degree Celsius as well as degree Kelvin also. Now let us check if temperature, let us say T1 is equal to 0 degrees Celsius and T2 is equal to 10 degrees Celsius. Then what will be T1 in Kelvin? It is 273 Kelvin, and T2 will be, it is 283 Kelvin, right? Therefore change in temperature, which is nothing but T2 minus T1, temperature difference, temperature difference. Let us put here degree Celsius value. If I write 10 minus 0, let us put Kelvin value, 283 minus 273. The same answer we will get, that is 10 degrees Celsius is equal to 10 Kelvin, right? But it is a temperature difference, and as it is a logarithmic mean temperature difference, the temperature difference in degrees Celsius is always equal to Kelvin. Therefore your answer is 57.7 Kelvin. Thank you dear students. In next lecture we will see one more numerical on this topic which was asked in previous year GATE examination.